All the four microphones have been connected to the impedance tube. Now going on with the software setup. Inlet surface is 950 mm square, outlet surface 950 mm square. Sample thickness is 1 as no specimen is been connected to between impedance tube. Third one is atmospheric pressure, and the fourth is 24 degrees Celsius, that is the room temperature. X12 and X34 is 29 by default, as you can see from the distance between the two microphones, 29 mm here itself. No specimen is there between the tube, so 1 mm, and the tubed OD is 34.8 mm. So calculating the surface area, 34.8 mm square. Divided by 4 into pi, and that equals to 951.148. So taking approx 950 inlet surface and outlet surface mm square, clicking on channel setup, it turns on green, that is setup is okay. Fine. Now phase calibration. You can see HC all, HC13, HC23, HC43, means by default this is phase calibration, changing 1 and 3 microphone, 2 3 microphone, and 4 3 microphone. So first taking the reading of HC all. Before taking this HC all, ensure the anechoic termination is been attached at the end of the tube. You can see anechoic termination. So anechoic termination is our foam sheet. So it should be put 1/3 foam sheet into the impedance tube. Before measuring HC all, before starting with HC, we can ensure if the signal is showing. Going to the scope, starting the source, and yeah, you can see graph. Also the sound is been received. Putting back again foam sheet. Stopping the source. You can see starting the source, stopping the source. Okay, fine, everything is working. STL in tube, going back to STL in tube, setup is okay. Phase calibration, HC all, HC all is by default the position of 1, 2 and 3 and 4 A, B, C, D, the all 4 microphones. This is known as HC all and we are calibrating it, so measuring standard position of it. We have put the anechoic termination, that foam sheet. This is mic A nearer to the speaker, mic B, mic C and mic D. Mic C is the reference. Okay, we are done measuring standard position. Starting measuring standard position. So the buzzing sound has been stopped as because HC all has been calculated, and this is the graph shown of phase calibration HC all. HC all has been calculated. Now clicking on HC13, so that we have to change microphones 1 and 3 and see, we have to measure 1, 3. So this is a graph being shown like this. We have to change 1, 3, means the microphone 1 and microphone 3. We have to exchange it. Okay. So I am showing microphone 1 and 3. I will exchange it and show you. See, now you can see microphones 1 and 3 have been exchanged. Before there were 1/4 on 1 and 2, and 3 and 4 was on half inch. So now it is half inch, 1/4, 1/4, half inch. That is microphone C, microphone B, microphone A and microphone D. So A and C have been exchanged. Okay, now we take the reading, turning it on HC13. We'll measure HC13. See, the now noise has been stopped. That's because the output signal has been completed. It's measured. It's showing now green. HC13 is showing green. Yeah. Now we need to exchange. This is the graph of HC13. Now next is HC23. So we need to exchange mic 2 and 3. That is mic B and mic C. Swap mic B and C. So here right now it's mic 1 and 3 has been swapped. So we have to swap this into the initial position and then swap again to 2 and 3. So we have to swap again mic B and mic C. Okay, fine. Bringing again back mic A, B, C and mic D to the again initial position, and now we need to exchange swap mic 2 and 3. Okay, mic 2 and 3. Now you can see that mic 2 and 3 have been exchanged. That is mic A, that is mic C, that is mic B and mic D. Means mic B and mic C have been exchanged. Fine. Okay, now continuing with measurement. Measuring mic 2 3 HC23. Okay, here we go. This is the graph of HC23 before measuring. Now we'll see after measuring what it comes. You can hear no noise now, means the measurement has been taken. And here you can see HC13, the light has been turned on. Here is a graph of HC. So now is HC43. We have to exchange mic 4 and 3, that is mic C and D. So here right now position of mics are mic A, mic C, mic B and mic D. So we need to put this all four microphones in the standard position and then change mic 4 and 3. Putting back the all microphones in standard position, mic A, B, mic C and D, all the microphones. So we now need to exchange mic 3 and 4, that is microphone C and microphone D. So just show you after changing the microphones C and D. After changing the microphones C and D, C series is A, B, D and C. So changing the microphone 3 and 4, we'll take the measurements. HC43. Graph of HC43. Clicking on measure 43. The noise has been, output has been stopped as the measurement has been taken. You can see everything is green. Everything is good, measured. Here is the graph of HC43. So ensuring everything has been measured, HC calibration, phase calibration has been measured. Now putting back all the microphones, now it is right now mic A, mic B, mic D and mic C. So putting back the mics in microphones into A, B, C, D, we have to change the microphones order of 4 and 3, that is microphone C and D, and put them back into the standard position. Back all the microphones A, microphone B, microphone C, and here last one microphone D. So means setting up all the microphones in standard position. And lastly, again after phase calibration, again going into STL and tube, the phase calibration turns green. So phase calibration is okay. Here we need to create a new section or rename this section as trial run. Trial run 1. No specimen. So changing this to no specimen. Here is measure rigid. So keeping rigid termination, here it's showing rigid termination. So you have to keep rigid termination in STL in tube. So here is the rigid termination. So we'll just put it. Removing this anechoic termination. Connecting rigid termination, we'll take the measurement with rigid termination. So measuring load rigid 1. Measuring rigid termination. I don't know, this error has been come. Okay, we will select OK and go ahead. Measuring anechoic with now replacing this rigid termination with the foam sheet anechoic termination, that is this foam sheet, keeping it 1/3 as we kept it before. Measuring anechoic. The signal has been stopped, so no noise. So now you can see all the things have been turned on green. Phase calibration, my measure load 1 rigid, measure load 2 anechoic, and in here processing, here shows transmission loss trial underscore run 1 no specimen project 1 HC project active project. So clicking on that and clicking to display, we can see a graph. This is nothing but the STLN tube with no specimen. Clicking on this right click, options, takes a grid, turning this 2 to 0 and again bottom 2 to 0. We can see the grid lines being appeared. Similarly for the x-axis, options, take grid 0 0, apply, OK. We can select double cursor, x-axis, and double clicking on the one cursor, one of that cursor, you can clicking 0, another is 5000. Right clicking on it, calculations, RMS is 35 dB, and again clicking on it, we can get average, that is 0.73 dB. So you can see 0.73 dB, RMS is 35, and here's the STL in of tube graph. So this is all of STL tube procedure, transmission loss measurement without specimen. We can also navigate this into the graph by selecting front back, STL in tube, project 1, STL in tube. You have to click and drag it, and here is the graph of amplitude versus hertz. So formatting it into the dB level, you can see -30, clicking it to ranging it 30, it's quite low, so 75 is good, I think so. Right clicking on it again, options, zero, apply, OK, options, zero, apply, OK, double cursor, X, 0, 5000, right clicking on any of the cursor and selecting calculations, RMS, you can also select from here, calculations, average. Here it is showing 50.58 dB RMS. To check it out, what's the difference between this and that? I have no idea. It's 0.67 RMS in this. 0.73 is RMS is here and 35.88. Navigator is showing something else. .67, showing 0. Okay, let's check out with this. Okay, fine, that's the end of the session. Fine, thank you.